So yeah, good morning everyone. So in today's session, we'll be discussing about hierarchical clustering. So hierarchical clustering is one of the alternative for partitioning clustering. So in previous sessions, we have learned about k-means and k-medoids algorithm, which are completely based on how do we partition our data. But this is something a better or easy concept to understand compared to the previous concepts. So what we'll do here, instead of partitioning the data points with respect to some calculations, we use a tree-based representation to explain about clusters. Okay, so as similar to k-means and k-medoids concepts, hierarchical clustering is also one of the unsupervised machine learning concept. And here we take some unlabeled data and we try to construct or design a tree, so that from that tree we will be forming some clusters in the form of dendrogram. So dendrogram is a key terminology which is actually linked to hierarchical clustering. So we come across the concept of dendrogram only in this concept called as hierarchical clustering. Okay, yeah. So what do you mean by a dendrogram? So I would like to show you what actually is a dendrogram. So here you can see the pictorial representation of a tree, right? It looks something like an inverted tree. So this is called as dendrogram. So here you can see the structure of two different algorithms. One is bottom to top called as agglomerative, and from its top to bottom called as divisive. So we can say the types of algorithms which are involved in hierarchical clustering are agglomerative and divisive. So there are two different types of algorithms which we'll be learning in the upcoming slides. Okay, yeah. So talking about what actually is a dendrogram. So a dendrogram, or a diagram called as dendrogram, graphically represents the hierarchy and is an inverted tree that describes the order in which factors are merged. So it can be bottom to top, or it can be top to top down approach. So this is the basic understanding of what is a dendrogram. Okay, so why should we learn hierarchical clustering? What is the use of hierarchical clustering when already we have k-means or k-medoids clustering? So as already discussed, k-means and k-medoids algorithm are having some challenges. They are not suitable for some large data set. Likewise, there are some different challenges which need to be addressed. So to overcome those challenges, hierarchical clustering came into picture. So what is the advantage of learning this algorithm is? In k-means and k-medoids algorithm, we need to specify the predefinedly number of clusters. For example, we need to at the beginning of algorithm only, we need to mention what is the value of k. Then only we can move ahead with the clustering concept. But in hierarchical clustering, there is no need of priorly mentioning the number of clusters. So according to the data points what you are having, we move according to the algorithm and we get the final clusters. Okay, so to solve the challenges, we can go for this hierarchical clustering, because in this algorithm we do not need to have the knowledge about predefined number of clusters. That is the main reason why we are learning hierarchical clustering. Okay, yeah, this is a pictorial representation for different types of hierarchical clustering. So we can see here there are two different types of hierarchical clustering, that is agglomerative and divisive. So one is also called as AGNES, Agnes, or divisive is called as divisive analysis, or in short form it is called as DIANA. Okay, yeah, that is the abbreviations. Okay, so talking about the different types of hierarchical clustering, as I already mentioned, there are two different types of hierarchical clustering. First one is agglomerative and second one is divisive. So agglomerative is a bottom up approach where we take individual data points, or we can say, for example, I'll take some data points like 1, 2, 3, 4, 5, 6. So I'm having individual values and I'll try to group them till the last step. So that is how agglomerative algorithm works on. But divisive algorithm is quite reverse to agglomerative algorithm. So here we will take a large data set and we'll try to divide them into single points. Okay, so I can show this pictorially to make you understand what is the agglomerative and what is divisive clustering according to step by step. So Look at the agglomerative algorithm here. You can see here, yeah. So I'm having some data points initially like A, B, C, D, E, F. All these are different points. So in step one, what I'm doing, I'm taking all these data points and whichever the points are similar. For example, here we are considering B and C are similar points. So they are grouped into one place. Again, D and E are similar. They are grouped into another point. So likewise, in step two, I'm combining the points which are similar and moving to step three. And again, in step three, what I'm doing, I'm combining the value of D, E with F because that looks something similar. So likewise, I'm moving till step five and finally combining all the values at one place. This is how I am forming some cluster. But what is happening in divisive algorithm? In divisive algorithm, it is completely reverse. Whatever you are going to apply in this agglomerative algorithm, we are just moving the same concept in reverse order. That's why it is called as the reversal approach of agglomerative algorithm. Okay, yeah, here you can see initially taking all the points and according to the this is the step one, and finally we are moving till the last step of your algorithm. Okay, yeah. So this is a pictorial representation or understanding of types of hierarchical clustering. Okay, any doubts still here, guys, to anyone? Yeah, we'll move ahead. So talking about the first algorithm called as agglomerative clustering, as I said, it is also having an abbreviation called as agglomerative nesting. In short form, we call it as AGNAS, Agnes, right? So what is this algorithm? What is the meaning of agglomerative? As I said, it is a bottom to top approach. Initially, we consider every data point as an individual cluster. That's what we have seen here. Here you can see individual data point is considered as one cluster. From there, we'll be starting the concept. Yeah. And at every step, merge the nearest pairs of the cluster. That's what we have seen here. At every step, I'm going to merge the nearest point. In step two, we have merged B and C and D and E. In step three, we have merged D, E with F. And in step four, I have again combined B, C, D, E, F. Likewise, in the last step, I have grouped all the points into single place. This is how we are going to move ahead with the agglomerative clustering. Okay. So at first, every data set is considered as individual entry or individual cluster. So at every iteration or at every step, the clusters merge with different clusters until one cluster is formed. So at every step, we are going to combine the clusters, and finally we are going to combine as a single cluster. Okay. Yeah. Now, let's try to understand the step-by-step procedure, how actually agglomerative algorithm work. So, look at the graph here. You're having some data points which are like you are going in a different space. So here I can say I'm going to form two clusters. By looking into the data, we can say we can form two clusters. So initially, there is no need of specifying number of clusters, but by looking into data, we can have an understanding like how many clusters we are going to form. So what is step one? Create each data point as a single cluster. So initially, each data point will be considered as a single cluster. So let's say there are n data points. So here you are having 6 data points. So number of clusters is equal to 6, right? That is the step one. So moving ahead, step two. In step two, what we need to do? We need to look for the similarities, and whichever the values which are nearer or whichever the values which are looking alike, those will be considered as the next step of this algorithm. So take two closest data points or clusters and merge them to form one cluster. So here we are taking two values into one place. That's why we are getting one cluster, and remaining points are considered as other clusters. So what happens in step three? In step three, again, I am going to combine these two values and change its color. Here you can see, here we are having the color indication like blue and light yellow color, right? So now once I move here, you can see the colors are being changed. That is, those points which are similar are grouped into single color. Again, if I move to step 4, so in step 4, what is happening? Instead of 2 points, I am going to take 3 points as single cluster. Likewise, whichever the points are similar, those will be grouped into one place. That is what we call it as the agglomerative cluster algorithm. Okay. So again, moving ahead, here you can see the number of clusters, the points in each cluster is equal to 3. At the initial stage only, we have discussed about this, right? So here we are getting 3 different points which are in the similar region or which are at the same distance level. That's the reason we can say we are finally getting 3 different clusters. But according to agglomerative clustering, what should we do? We need to finally combine all of them into at a single cluster. So once all the clusters are combined into one big cluster, develop the dendrogram to divide the clusters as per the given question. So what I'm going to do here, we are going to divide the cluster points into dendrograms. Dendrogram means a tree-like representation. So finally, according to agglomerative clustering, if you are looking back once more, you are having some data points like this, and from these data points we need to form a single cluster. So for that, I'm randomly selecting one point here and I'm combining with the next point. Yeah, as you can see here. Next, similarly, I'll do it in the same different region again here. So here you can see again the values are something again combined into different phase with different colors. Okay. Yeah, again moving for the next step, instead of 2 values I can take number of values as 3. Yeah, so here you can see number of values is equal to 3, and the same happens in the different region also. Finally, I am forming 2 clusters, and according to the agglomerative algorithm, we need to form number of steps is equal to number of clusters is equal to 1 at the end. So I am grouping all those points into single cluster. Now the challenge is, how do I convert these data points into a, or this cluster into a dendrogram? So that's what we'll be looking into. And for doing that, we need to follow some methods like measure for the distance between 2 clusters. So if you want to construct a dendrogram and merge those points into clusters, we need to use some methods. So these are the common discussed techniques or methods which we need to follow. Okay. Yeah. So how did we group these points? According to the distance only again here. So according to the closest distance or the nearby neighbor of that value, we are going to combine, right? So as we have seen, the closest distance between the 2 clusters is crucial for hierarchical clustering. So if I want to form clusters or group points into some clusters, distance plays an important role. Okay. So there are different distance calculation, as we have seen a number of times, like Euclidean distance, Manhattan distance, and there are different distance calculation metrics for hierarchical clustering also. Okay, so in terms of hierarchical clustering, we call them as linkage methods. So the following are the linkage methods, like you can see single linkage, complete linkage, average linkage, and centroid linkage. So apart from these 4 linkage, we are going to also have one technical word called as Watt's algorithm, which is also used in hierarchical clustering, but that is not relevant to our syllabus. So I am skipping that. Okay. So initially talking about single linkage. So what we are going to do here, we are going to do like calculate the shortest distance between the closest points of the cluster. So I am having, for example, we are taking this data space. So here in this cluster, I am having how many points? 6 points. And here I am having 5 points. So if I compare these 2 clusters, the nearest point of this cluster to this cluster, that distance is computed. That is, the shortest distance between the closest points of each cluster is computed. This is what we call it as single linkage. Okay. So moving ahead, we talk about complete linkage. So here what we are going to do, here we are going to look at the farthest distance between the 2 points of 2 different cluster. So it is quite opposite to the single linkage. So there you are going to take the shortest distance between 2 points of a cluster, and here you are going to take farthest distance between the 2 points of 2 different cluster. Okay. Yeah. So this is one of the popular linkage methods, as it forms tighter clusters than single linkage. So according to the data points or number of points you're going to take, so sometimes we use complete linkage and sometimes we may use single linkage, but comparatively complete linkage method is much widely used when compared to single linkage method. Next, the average linkage is very simple, like the centroid calculation in the K-means algorithm. So you are going to calculate the average values and that distance will be computed. So as given, you can see it is a linkage method in which the distance between each pairs of data set is added up and then divided by the total number of data sets. That's what we call it as average. So it is also one of the most popular linkage method. So whenever you are having some confusion between the largest and shortest, farthest or smallest point, then we may go for average linkage method. And the final linkage method is again centroid, similar to your K-means algorithm. Centroid values are calculated for each data point and centroid distance is again computed. Okay, so these are the 4 linkage methods which we need to learn when learning hierarchical clustering. Okay, now let's look into how to divide the number of cluster points into a dendrogram. So this is the final step of hierarchical clustering and very important step. Okay, so this is what we're calling as working of dendrogram in hierarchical clustering. So the dendrogram is a tree-like structure that is mainly used to store each step as a memory that the hierarchical clustering algorithm performs. So each step that we are trying to store some values. Okay, so in the dendrogram plot, what is x-axis and what is y-axis? X-axis shows all the data points of the given set. So here you can see in the table here you can see x-axis represents the data set values and y-axis gives the Euclidean distance values. Okay, so x-axis always indicates the data point values whatever we are given in the problem statement, and y-axis gives the Euclidean distance of that points. Okay, so now the main understanding here is how should we convert these values into a dendrogram. So here you can see there we have taken the values with the names like P1, P2 and P3. By looking into this graph, we are going to perform now number of clusters need to obtain. So these points are taken like P1, P2, P3 into one cluster and P4, P5, P6 into cluster 2. Yeah, this is what is the observation. Now, according to that, you can see initially P1 to P2. So P1 is in another point and P2 and P3 are shown here. So P2 and P3 are combined here. You can see here initially P2 and P3 are combined because they are very similar. And again P1 is combined with P2 and P3. You can see here the representation. Okay, yeah. So in the above diagram, the left part is showing how clusters are created in agglomerative clustering and the right part is showing the corresponding dendrogram. So this is the left part showing number of clusters and right part is showing how dendrograms can be calculated. So I have explained a step-by-step method here how to merge the data points and form a dendrogram. In the first step, the data points P2 and P3 are combined. As I said, P2 and P3 are grouped into single place according to their distance, and because they are neighbors, they are combined. And next, what we are happening after that, the rectangular shape is obtained. The height is decided according to the Euclidean distance between the points. So according to the distance between P2 and P3, we are going to determine the height of that value. Okay, yeah. So here you can see the height is something around 6. If I look into P5 and P6, the distance might be something similar to 8. That's why the height is given as 8. So this is one important observation. What you need to, whenever you're going to answer in examination point of view, in y-axis, you're going to have distance value. And according to the distance value computed, you're going to design the size of height of this dendrogram. Okay. Next, P5 and P6 form, yeah, you can see P5 and P6 form one point here or one dendrogram here. Okay, yeah. P5 and P6 form a cluster and the corresponding dendrogram is created. So according to the distance, Euclidean distance, we are going to decide the height, and you can see P5 and P6 is a little bit greater than P2 and P3. As I said, P5, P6 is having the distance around 8 and here we are having distance around 6. So according to distance value, you are going to design the height. So finally, after merging all the things, you are getting 2 clusters. Okay, yeah. This is how you're going to understand the agglomerative cluster. At the end or the last step, the final dendrogram is created, and that combines all the data points together. Okay. Yeah. So next, moving ahead, next we are going to discuss about divisive hierarchical clustering, which is a quite opposite step of agglomerative clustering. Okay. So in short, we can say that divisive hierarchical clustering is precisely the opposite of agglomerative hierarchical clustering. Okay. So in divisive method, we take into account all the data points as a single cluster. So as I have pictorially represented the algorithm, it can be simply considered as the reversal process of agglomerative clustering. You're going to take initially all the points, and from there, step by step, you're going to divide them into individual clusters. That is what we can learn about divisive clustering. But in real world, divisive clustering is not muchly used. Agglomerative clustering is only mostly used. Okay. Yeah. So now let's move for the next concept, that is advantages and disadvantages of hierarchical clustering. So talking about advantages, so as already mentioned, similar to k-means. So in k-means, we need to specify the number of clusters at the starting phase only. But here, you're not going to specify number of clusters. So according to the data points given, you're going to find the distance and form the clusters. So no prior information about number of clusters is required, and comparatively it is very easy to implement and gives best result in some cases. So okay, that is the major advantage. So now let's go for the disadvantages, which are more compared to advantages. So once we compute any step, there will be no undo option. That is the major drawback of hierarchical clustering. And the time complexity and space complexity are also more. Looking at the slide, we can see time complexity of is at least big O of n square log n. At least of this is required for completion of each step. That's a major drawback of hierarchical clustering. Okay, and based on the different types of distance values, that is, it can be single linkage or complete linkage. There are some again drawbacks, like it can be sensitive to outliers and noise. It can cause breakage of clusters, difficult to handle different sized clusters and different convex shape. So there are some disadvantages which we can see here. And sometimes it is difficult to identify the correct number of clusters by the dendrogram. So if we are having some lakhs of data points at that time, uh, dendrogram might not be best suitable. Okay. And talking about strengths and weaknesses, strengths of hierarchical clustering are that it is easy to understand and easy to implement. And talking about weakness, it rarely provides best solution because of the time complexity and high space complexity. For larger data set, it is not muchly preferred. It does not work with missing data. It does not work well with mixed data type. And finally, the main output dendrogram is commonly misinterpreted. Okay, this is how we are going to have strengths and weaknesses of hierarchical clustering. Okay.